So I'm going to, it's a real pleasure to open this. It looks like a really exciting afternoon of talks. I'm going to kick things off talking about the state of the planet and a blueprint for a green future. And the context of this is that I'm looking to describe how we can look to rebuild our global economies as we recover from the current pandemic. But if we to do so in a way that builds stronger, more resilient economies, then we've also got to face head on the other threats that are that we are facing at the moment, and in particular those of social inequality, both within countries and across the world. So it's estimated that the richest 1% have more than twice as much wealth as 6.9 billion people, a huge percentage of the global population. The threats posed to our natural world by extinction, and here a report from a year or so ago estimated that around 1 million species are at risk of extinction in the next decades. And of course, the threat posed by climate change, where we're already seeing the impacts of climate change being felt in terms of extreme weather around the world, repeated episodes of flooding in this country affecting lives and livelihoods of communities. We've seen devastating images of wildfires this last year in California and in Australia, for example. So as been mentioned in the introduction, there have been a couple of reports that come out just in the last few days. The Royal Society report on digital technology and the planet, which this conference is focused around. Yesterday's sixth carbon budget from the Committee on Climate Change, and Cambridge Zero, which is the initiative in Cambridge University that I lead, the response of the university to climate change, released a report a couple of weeks ago on a blueprint for a green future, looking at how we could enact a green recovery from climate change. And I'm going to talk a little bit about some of the findings of all of these reports in my presentation. Other people are going to be following up with further details in other presentations throughout this afternoon. So let's just focus on climate change and the state of where we are today. This is, if you like, a dashboard of how the world has changed over the last 150 or slightly more, 175 years almost now, in terms of key measures of our climate. So we've seen almost now a 50% increase in carbon dioxide levels in the atmosphere. And of course, that has been predominantly due to the use of fossil fuels for energy. And you can see that graph there showing 20-fold increase in energy use over that time period. The deforestation and changes in land use and industrial processes have also been an important part of that increase in carbon dioxide levels. And carbon dioxide, of course, is a greenhouse gas, and so you'd expect an increase in temperature. And indeed, we've seen now over 1 degree Celsius of increase in terms of global average surface temperature. And that's not the only impact. One example, and that's the one that I've shown here, is that as you warm the world, the oceans warm and the water in the oceans expands in volume, rising sea levels. But additionally, we've seen really significant melting of ice, especially in the polar regions, and where that ice is sat on land, it melts, finds its way into the ocean, and that also raises sea level rise. We are seeing an acceleration of that melting of polar ice at the moment, and an acceleration in sea level rise. And as we continue that warming pattern, the risks multiply. The risks to people in terms of extreme weather, the risks to our natural world, which, as I've already described, is already under significant pressure. And also the dangers of really catastrophic change. And the sorts of things that we're concerned about in terms of catastrophic change are the rapid switch of the Amazon rainforest into savanna, the potential collapse of the vast ice sheets covering Greenland and West Antarctica, or the release of vast stores of frozen methane from the Arctic. So in the context of all of that, what role does digital technology have? And I want to emphasize two key roles of digital technology. The first one is assessing and monitoring those risks. And the second one is contributing to sustainable solutions. So if we take that first example of how digital technologies can help us to assess and monitor the risks, we really now have more data than ever before, vast data sets from satellites, from network sensors, from computer simulations of the climate, from crowdsourced information telling us about how our world is changing. Tens of terabytes of data coming now each day from space, from large satellite missions by European Space Agency and other agencies, but increasingly from private sector putting small low-cost satellites into space. And the other example that I have on this slide is an amazing network we now have of ocean floats, sampling the ocean from the surface down to, in some instances, 6,000 meters, giving us unprecedented information about how the oceans are changing. Now we can bring all those different data sets together to help us understand the risk, and we can deploy new advances in computing technology in order to do that. One example where there's a lot of work going on at the moment is looking to see how we can apply machine learning methods. For example, to combine together data from climate computer simulations, climate models, together with historic observations to get us unprecedented information about the likelihood of extreme weather events exceeding specific thresholds that could cause damage to society or to businesses. And here's just one example of some work that I've been involved in, looking at how we can better predict the likelihood of particularly disruptive weather conditions in cities into the future. Now, the other side of this is how we can use digital technologies to contribute to sustainable solutions. This graph here encapsulates the challenge that we have of responding to climate change. What you see in terms of the white dots are, for the last 4 decades, the emissions of carbon dioxide globally. And you can see that they have been steadily increasing year on year on year. The blue curves that you see here is the direction of travel of those emissions that we need to be on if we are to have a good chance of limiting temperature rise to 1.5 degrees Celsius. And as I said right at the start of this presentation, we're over 1 degree Celsius already. You can see an estimate of what the emissions for 2020 are likely to have been, a dip of around about 7% in terms of our emissions compared to last year, as a consequence of the global lockdowns that we've seen to our economies over this last year. But the really key message from this is that 7% decrease that we'll have seen this year is only the scale of decrease that we need to see year on year on year for the next decades if we are to stay within that blue pathway. So there is a really significant challenge. Now, those decreases need to happen across every sector of the economy. You can see here, looking at the UK, how our emissions have changed over the last decade or so. And what you can see is there's been a significant decrease in that red curve in the energy sector over the last decade. And that's come about predominantly because we use very little coal now in our generation of electricity, and also through other efficiency savings. But what you can also see is that almost every other sector has seen very little change. Of course, it depends exactly how you define these different sectors. You get slightly different graphs according to those definitions, but broadly that story is true. And so the challenge is, where can we be using digital technologies in order to help bring those emissions down to zero? And of course, the UK has a target of reaching net zero emissions by 2050, and a new ambition of 68% reduction on 1990 emissions by 2030. So this is another way of looking at that same data. This is the radical transformation of our economy and society that's needed. You can see there the image of what our emissions looked like in 1990 across those different sectors. Significant reduction from 1990, already in some ways a radical transformation, not that we particularly noticed it, and a significant reduction in our emissions by 2020. Each of those squares that you see represents the same amount of emissions, but then roll forward another 30 years to 2050, and we need to have made that much greater a change still. Yesterday, the Committee on Climate Change produced a report, and I really recommend either watching the presentation that was put out yesterday at the launch of that report, or diving into the report itself, because it really does provide a blueprint of how to get to net zero as a country over the next couple of decades. And the two images that I've presented here from that report, on the one hand, show exactly how across those different sectors of our economy we could be reducing our emissions to make that net zero by 2050 target. And then the other image shows how that could be achieved through a combination of measures that involve changes in our technologies, changes in the way that we use our technologies, and indeed societal changes themselves. So that might be changes in the way that we produce our energy, changes to the way that we use our transport. And we know that we're going to be moving more and more to electric vehicles in the very near future, but then also changes, for example, to our diet or to our frequency of flying. Now, there really are huge opportunities across each of those sectors, both from digital technologies and from technologies more generally. And I wanted to just give you a few examples from each of those. And there will be more examples being presented in other presentations throughout the rest of this afternoon. So let's take the energy sector first of all. The example that I've got in the image here is some research that's being undertaken in Cambridge that's looking at how we might be able to develop artificial fuels into the future, essentially recreating what a leaf does, but in a lab instead, to produce the fuels of the future. There's also really exciting opportunities in terms of using digital twins, computer simulations that are twinned together with real life examples. Wind farms is one example where this is being used, to see whether or not those digital twins can be used to help the real world twin of that operate more efficiently. In terms of transport, there are huge opportunities for switching up the way in which we interact with transport into a service for mobility. And how digital technologies can help with that. The other example that's shown here is work that's being undertaken to try to deliver net zero aviation over an accelerated timescale. So that's either looking at using sustainable fuels or looking at how we can electrify aviation. In agriculture, one of the huge opportunities that's already starting to be implemented is to see where we can use digital technologies to undertake agricultural practices more efficiently. Precision farming that enables us to use less fertilizer and effectively use our resources more efficiently. Waste is a huge problem, and it's just common sense to try to reduce our waste, reduce our footprint on the earth. And if we can use digital technologies to help generate a more circular economy, then we will go a significant way towards making progress in that area. In terms of buildings, this is perhaps an example where people are already familiar in their workplaces, or in some instances in their homes, of how digital technologies can help us run our buildings more efficiently. But in terms of other technologies and other developments, there's also a real challenge looking at how we can develop new construction materials. Cement and steel produce huge amounts of emissions, and if we can use more natural construction materials, then we would significantly bring down the emissions in those sectors. There are parts of industry that are hugely, that produce large amounts of emissions in terms of those industrial processes. So can we use the latest machine learning AI technologies to help us design, identify new industrial processes that are less emitting in terms of greenhouse gases? And then the final example that I have down here is forestry. This is about how can we find ways of actually taking greenhouse gases out of the atmosphere. Trees themselves do it, but we may also be able to develop technologies, artificial trees, if you like, to take those greenhouse gases out of the atmosphere and store them safely away from them having that climate change impact. So that's just some examples of the technologies that could be developed. Some of them using digital technologies, some of them using other research and development. Bringing that all together, the report that we put out a few weeks ago on a blueprint for a green future looked at that very holistically through a set of different lenses. So some of it is about the technological development and how can we put in place these structures in order to accelerate the timescale for those innovations, both being developed and then rolled out at scale. But it's also all sitting in a wider context of how we can transform our economy and support our economy to move towards a greener future. How can we help society to make those changes? And I've already described how, on the one hand, we also need to be addressing those challenges of social inequality. So any of these technological solutions that we're developing, we need to be ensuring that they are rolled out into society in ways that are fair and just and don't exacerbate those social inequalities. But we also need to be looking to see how we can use technologies to help democratize this process of moving to net zero. How can we put in place technologies that help engage people in the process of society moving to net zero? I've mentioned some aspects of infrastructure in terms of the way in which the building sector can be decarbonised. Looking at some of these sectors, well, in fact, all of these sectors in a really from a really systems perspective, but then also connecting them together so that we're not looking separately at one sector from another sector. If you're looking at the way in which we're building infrastructure in terms of the physical infrastructure, we can't do that without looking at our transport strategy, for example. And one of the key recommendations of the Royal Society report was that if we're really going to address this in a systematic way, we need to be looking at putting together a task force that crosses through government departments, looking at how digital technologies can help support a net zero transformation. And similarly, one of the key recommendations from our Green Recovery report from Cambridge Zero was that we should be looking to put in place a net zero delivery board, the sort of organisation that we had that delivered the London 2012 Olympics, joining together government departments, but not just at a national level, linking down into local government, linking across into the private sector and linking through into NGOs and indeed into civil society more generally. The final two things that I want to mention that are the other lenses that we looked through this. First of all, nature, the importance of supporting nature. I've already described how trees can be used, if it's the right trees planted in the right places, to help remove carbon dioxide from the atmosphere. We can look at other measures as well, restoring our peatlands, for example. But more generally, how can we look to restore our natural worlds in the ways that help biodiversity and help climate change at the same time? And then finally, I can't not mention the international context. This coming year is an incredibly important year for climate change. In November of next year, the UK is going to be hosting the next big climate conference, COP26 in Glasgow, and the UK holds the presidency along with Italy of that climate conference. So much is going to ride on the scale of ambition that is developed by countries around the world over the course of the next 12 months and then delivered in Glasgow in November. It's a really exciting opportunity, and overall this provides a really exciting opportunity to, if you like, it's almost a reset moment. terrible though the last year has been for societies around the world, we now are in a position where we have an opportunity to think, what is the sort of future we want to create and how can we create it? What infrastructures, what policies, and what broader responsive society do we need to be putting in place to develop a better world? Thank you.
Okay, thanks very much, Emily, for that brilliant kick-off talk for us. That's been really helpful. I've got one or two questions that have come in on the chat line for you. There's a couple of questions of clarification. One was about the slide that had the graph of emissions reductions between 1990 and 2020. And the reduction needed by 2050. The questioner wanted to know, are these values total or per capita?
Those are total. Well, I mean, per capita, when you get to zero, it doesn't really matter if it's total or per capita, it's still zero. Yeah. I don't, where there were numbers on there, it was total emissions for the UK that I was showing.
Okay, and then a second question was about the slide that had the reduction graph. You know, the factors that rested behind the reduction in 2020, the CO2 reduction in 2020, was that merely COVID related, or did it include implemented policies? And do you expect the same reduction to hold good over 2021?
So the reduction, so as I described, we've seen, it looks like we're going to have seen about a 7% reduction compared to 2019 in terms of our emissions. I would say that that's almost certainly entirely due to the global lockdowns of economies. And so, you know, you wouldn't expect to see that lasting, in the sense that I think we all hope that we're not going to be locked down as much as we have been over this last year. But I think, you know, the real challenge is, are there some aspects of what we've all been forced into over the last year that we can persevere with? So, you know, I think it's, you know, are we really going to be going back to traveling as much as we were previously, commuting into work for those that did previously every day of the week? Possibly not. Are we going to be flying around the world to international conferences as much as we have done previously, now that we everyone has realized that actually it might not be quite the same, but on many levels we can undertake some of those activities virtually? So, you know, I think the hope is that some of those changes will be lasting, but the real challenge is that we've got to achieve those sort of levels of reduction that we've seen this year on year, and we've got to do it in a planned rather than an unplanned way.
Yeah, thanks very much, Emily. There's another question about, you know, overall sustainability, because when we talk about the drastic electrification in the transport sector that's required, you know, some commenters look at the utilization of key constituents like cobalt and lithium, which are, you know, sensitive topics in terms of mining and how that impacts the countries which hold the reserves, like the Democratic Republic of Congo for cobalt and Chile for lithium, amongst others. How do we square that circle? And also, you know, given the quantity that's required and the fact that every nation is going to be trying to do the same things, is it realistic that we can look to electrify cars as we currently do with batteries?
Yeah, well, so I mean, exactly that issue is one of, you know, is a key topic in terms of battery research. How can we look to be developing battery technologies in a way that is sustainable, in a way that we increase the recyclability of the products, and we use less natural resources as part of those, especially rare natural resources, as part of their production. So, you know, I absolutely agree that taking a holistic view of any of these solutions is critically important, so that you don't end up causing more problems through your solutions than you're trying to solve. That's the last thing we want to do. But it really does mean that you need to be taking a very multidisciplinary lens at all of these things. So it's not just about doing technology in a very narrow sense. It's about looking at both the other implications of those technologies, whether that's for the natural world or whether that's involving societal dimensions. And actually going back to the Royal Society report that has been just launched on digital technologies and the planet. A key element of that was focusing on the ethical implications of those technologies. So that's making sure that the technologies are being developed in the context of a societal understanding is just critically important. And also, of course, engaging people in the process of designing those technologies is also key.
Yeah, and also presumably driving towards, a holistic view of interconnectedness in policy, so that, historically we'd have had the different departments of state issuing their various policies separately. One would hope that the Royal Society report and the report from the Climate Change Committee and the Cambridge report, if they were looked at by the various departments of state, there'd be some recognition that we actually need a more integrated approach to how we drive towards net zero than historically we would have seen.
Well, indeed. And as I mentioned in my presentation, I think I was very interested that a key finding of those reports was precisely, it's not just about different government departments, coming together and looking at those reports. It's actually about putting in place the institutional infrastructure to enable on an ongoing basis a much more cross-departmental holistic view, and not just at a national level, as I described. That also needs to feed down into a local level and to branch out into other parts of society as well, because it's only by us all acting together in a really holistic way that we have any chance of enacting such a significant change to our global economies over such a very short time.
That's great. And I guess one last question, Emily, for you before we head over to Jim Ski. It's to do with the data that is now accessible to us from satellites and from monitoring devices that can be, launched very remotely, and the data read back from them. How big a difference is that making to our ability to assess, if you like, online at-line changes in the climate as it actually happens?
Well, as I described, I mean, we have literally unprecedented amounts of data now coming from all sorts of different sources, including from space, that tell us about all sorts of different aspects, not just actually of our climate, but of our natural world more generally as well. So, for example, if we're wanting to understand the rates of deforestation, critically important to have that information on the levels that are occurring and where they're occurring, but also in terms of, for example, our responses to climate change. If we want to, one project that I've just started being involved in is looking at how we might be able to better characterize the energy efficiency of specific buildings, and therefore target our responses in terms of energy efficiency measures through looking at data coming from satellites from space, ever increasing higher resolution, so that we can increase the pinpointing of that information. So the more that we have data to describe how our world is changing and what our responses to that, how effective our responses are to that, the more effective our solutions can be. But there is also a key element within that, is that the data is only useful if it's accessible and if it's can be easily brought together. And so again, there's lots in the Royal Society report that speaks to how do you put in place the structures to enable data to be more easily used.
That's great. That's absolutely fantastic, Emily. Really appreciate the keynote that you've just given us. So we need now to hand over to